Welcome to the journey of science and sleep, where we explore the wondrous stories of the universe together in a slow, gentle rhythm, allowing you to both learn and easily relax before bedtime. Tonight, we will pause at the only planet in the universe that harbors life, Earth, the small blue home amidst the endless void. From the shifting mountains, the vast oceans, to the atmosphere that nourishes us, all are writing together the symphony of life. If you enjoy these peaceful journeys, don't forget to subscribe, leave a like, and stay until the end of the video, because there I have a small gift just for you. And remember to hit the bell so you'll always be the first to step into the next adventures. To truly understand why Earth became a living planet, we need to turn back the clock, returning to the chaotic beginning when this world was first formed. About 4.5 billion years ago, the solar system was still an unfinished picture. Instead of the graceful planets orbiting the sun as we see today, it was only a vast disk of dust and gas swirling around a young star that had just ignited. Tiny dust particles, seemingly meaningless, began to collide, stick, and accumulate. From those fragments, planetesimals, the primitive building blocks of worlds, gradually formed. In this cosmic bumper car game, not all survived for long. Many celestial bodies shattered when collisions were too strong, while others were flung out into the cold depths of space. But a few winners continued to grow. Earth was one of them. Each collision, however violent, brought in more material, more energy, and step by step built a planet. At first, it was not the gentle green world we know today, but a molten sphere, glowing red in the darkness of space. At this stage, Earth was like a gigantic forge. Heavy metals such as iron and nickel sank to the center, forming a dense core. Lighter materials floated upward, creating the mantle and the primitive crust. This stratification gave Earth its internal activity, the hidden movements that still shape its surface today. The iron core would later generate a magnetic field to shield life from the sun's harsh radiation. But in the beginning, the planet was fragile, vulnerable, a seething sphere of magma surrounded by chaos. The early solar system was far from peaceful. Leftover fragments from planetary formation continued to speed through space. Earth endured a storm of asteroids lasting hundreds of millions of years. Some impacts were so powerful they reshaped the surface entirely. One such collision, believed to have been caused by a Mars-sized body, ejected countless fragments into space, which later gathered to form the Moon. This eternal companion not only brought beauty to the night sky, but also stabilized Earth's tilt, creating regular seasons, a foundation for life to develop. As the cosmic bombardment continued, Earth began to cool. A thin crust solidified over the molten surface. Gigantic volcanoes erupted, releasing carbon dioxide, nitrogen, and water vapor, laying the foundation for the first atmosphere. But the sky then was not clear blue like today. It was thick, toxic, and tinged red. Meanwhile, comets and icy asteroids from the outer solar system may have delivered water, seeding the beginnings of oceans. Gradually, low-lying valleys filled with liquid water and the primordial seas emerged. Imagine this. A world just cooling down, its surface still cracked by lava, but in vast depressions, oceans began to spread. Fire and water, two opposing forces, coexisted on a young planet. This contrast, volcanic eruptions darkening the skies and rivers of lava meeting steaming oceans, created an energy-rich environment, paving the way for the next miracle: life. Around 4 billion years ago, as the storm of asteroids subsided, Earth began to find a new balance. The crust thickened, oceans covered much of the surface, and the atmosphere, though still toxic, was evolving. The greenhouse effect kept the planet warm enough, even though the sun was weaker than today. Lightning tore through the dense skies, providing energy for chemical reactions. At the ocean floor, hydrothermal vents spewed minerals, creating diverse chemical gradients. It was like a vast laboratory, endlessly experimenting to prepare for a great turning point: the birth of life. If you could look at Earth then, you wouldn't see a finished masterpiece. Instead, the world resembled an unfinished painting, its colors still blending, its shapes still vague. There were no green forests, no breathable skies, no flocks of birds. But within that chaos, the foundational elements were ready. From the deep iron core, a magnetic field to protect the planet. From the moon above, tidal cycles would stabilize. From water and rock, chemical reactions would arise. All awaited the moment when the first sparks of life would appear. It was within this harshness that Earth became special. Other planets in the solar system were either scorched into deserts, frozen into ice worlds, or suffocated in toxic atmospheres. But Earth, small and blue, found a fragile balance between destruction and creation. And from that balance, a living planet was born. When we walk on solid ground, few people think that right beneath our feet lies an entire world in motion. Earth's surface is not a static block, but a vast mosaic of drifting tectonic plates. These plates slide, collide, and sometimes split apart as if the planet were performing an endless dance. Its rhythm is so slow that humans can hardly perceive it, only a few centimeters per year. Yet, when accumulated over millions of years, those tiny movements are powerful enough to open oceans, raise mighty mountain ranges, and redraw the face of the planet. Deep within the mantle, heat released from Earth's core drives convection currents. They stir the semi-molten rock, dragging the thin crust above along with them. Imagine the crust as a cracked eggshell floating atop a simmering pot of soup. This very motion is the engine behind all tectonic phenomena we witness: earthquakes, volcanoes, and the formation of continents. Where plates diverge, molten rock from deep inside Earth rises, creating new crust. The Mid-Atlantic Ridge is a magnificent testament to this process, an enormous underwater mountain range stretching across the ocean floor, where magma constantly surfaces, pushing the continents apart. It is hard to believe that just a few centimeters per year over millions of years could transform a small crack into the vast Atlantic Ocean. On the other hand, where plates collide, the scene is even more dramatic. One plate is forced beneath the other, the process of subduction. Magma produced from these sinking slabs erupts through cracks, creating giant volcanoes. The Pacific Ring of Fire, a chain of earthquakes and volcanoes encircling the world's largest ocean, is a direct consequence of this tectonic motion. And when two continental plates clash, the immense compression pushes rocks upward, forming colossal walls of stone. The Himalayas, with the towering Everest, are the result of the collision between the Indian and Eurasian plates, a process still ongoing today. There are also transform boundaries, where two plates slide past one another. The San Andreas Fault in California is famous for this. When plates grind against each other, built-up stress can be suddenly released, causing powerful earthquakes. People living there know that the calmness of the ground is only an illusion, hiding immense forces below. Interestingly, although sometimes catastrophic, these movements play a vital role in sustaining life. Volcanoes, when erupting, bring gases and minerals from deep within the earth to the surface. Their nutrient-rich ash makes the soil fertile, nourishing forests and farmland. Regions around volcanoes in Italy, Japan, or Indonesia are proof. Humans accept the risk in exchange for fertile lands. Earthquakes, though brief and terrifying, are a way for Earth to release pressure, preventing larger fractures that could tear continents apart. More importantly, plate tectonics regulate Earth's long-term climate. When a plate sinks into the mantle, carbon within sediments is dragged down with it. Later, part of that carbon returns to the atmosphere through eruptions. In this way, Earth maintains a sustainable carbon cycle, keeping the temperature neither too hot nor too cold. Without this recycling mechanism, greenhouse gases would either accumulate excessively or disappear entirely, both making the planet uninhabitable. The movement of continents also directly affects life. When the supercontinent Pangaea broke apart, plants and animals were scattered, forced to adapt to new environments. These separations drove evolution, creating the biodiversity we inherit today. Fossils found across distant continents, from identical ferns in South America and Africa to ancient reptiles in Antarctica and India, are clear evidence of the former unity of the continents. Astonishingly, the concept of plate tectonics was only recognized by science less than a century ago. Though people had long noticed the strange fit of Africa's and South America's coastlines, it wasn't until the 1960s that evidence from seafloor mapping and paleomagnetism confirmed the theory. Symmetrical magnetic stripes on either side of mid-ocean ridges were undeniable proof that the seafloor was spreading. From then on, a new picture of Earth emerged, a dynamic planet forever changing. Yet the most crucial secrets lie even deeper, at Earth's core. At the center, under immense pressure, exists a gigantic iron-nickel core composed of a solid inner core and a liquid outer core. Although temperatures there are high enough to melt metal, the immense pressure keeps the inner core solid. Surrounding it is a churning ocean of molten metal in the outer core, constantly in motion. The movement of this liquid metal produces a miraculous phenomenon, Earth's magnetic field. Electric currents generated by these swirling flows turn the planet into a giant magnet wrapped in an invisible shield. The geomagnetic field extends tens of thousands of kilometers into space, forming a huge bubble called the magnetosphere. This is the armor that protects our small planet from the sun's fierce particle storms. Without this magnetic shield, the solar wind would gradually strip away the atmosphere, much like what happened to Mars, a world that once had flowing water but is now barren. Earth was luckier. The magnetosphere deflects streams of charged particles, forcing them to flow around the planet. Only a small portion leaks in, colliding with the upper atmosphere near the poles, creating dazzling auroras. Those shimmering green and purple lights are not only mesmerizingly beautiful, but also living proof of the invisible protective shield at work. Thanks to the combination of plate tectonics and the magnetic field, Earth has become a unique world, a planet that breathes, moves, recycles itself, and shields its fragile life. It is not merely the solid ground beneath our feet, but a colossal machine, ceaselessly working, shaping the destiny of the entire planet. Water on Earth is not just a chemical element, it is the red thread connecting all life, the foundation for the planet's great and small cycles. The water cycle, from evaporation, condensation, rainfall, to the flow back into the oceans, is one of the most quietly operating yet most enduring miracles. Without it, Earth would be a vast desert, lacking the vitality we are familiar with. When looking at a cloud drifting across the sky, few imagine that inside it are billions of tiny droplets participating in a global journey, carrying solar energy, nourishing forests, grasslands, and even cities. If rivers are the veins flowing across the surface, then the oceans are the planet's giant heart. They cover more than 70% of the surface, store most of the heat, and regulate the global climate. Ocean currents, like massive conveyor belts, carry warm water from the equator to the poles and bring cold water from the poles to the tropics. Thanks to this, regions that would otherwise be too hot or too cold to live in become temperate, allowing life to spread widely. Without the oceans acting as a massive air conditioner, Earth would likely undergo far harsher fluctuations, perhaps even unable to sustain the civilization we have today. Within the sea, life explodes in ways the human eye can hardly imagine. From colorful coral reefs with thousands of fish species to the dark abyss where bioluminescent creatures create their own light, the ocean is a different universe. At hydrothermal vents, kilometers beneath the surface, where sunlight never reaches, life still thrives on geothermal energy. These strange communities rely on chemosynthetic bacteria, proving that life can develop without sunlight as long as there is energy and nutrients. This is also why many scientists believe that places like Europa or Enceladus, the icy moons of the solar system, may host life in their subsurface oceans. Water not only shapes climate and biology, but also leaves its mark on geology and human culture. Since ancient times, civilizations have flourished beside great rivers. The Nile nourished Egypt, the Tigris and Euphrates nourished Mesopotamia, the Indus and Yellow River nourished the brilliant civilizations of Asia. Rivers not only provided food and transportation, but also inspired faith, poetry, and art. Every drop of water carries within it the long story of both Earth's history and human history. Yet if water existed only as permanent ice or evaporated into gas, life would hardly be sustainable. Only when water remains liquid under stable pressure and temperature can biological complexity emerge. This is why astronomers, when searching for life beyond Earth, always ask one question: is there liquid water? The presence of oceans on our planet is not a simple coincidence. It is the result of a series of delicate balances, from the perfect distance to the sun, to an atmosphere thick enough to maintain pressure, and a magnetic shield protecting from the solar wind. Water is also the silent architect of landscapes. Its flow over millions of years can create magnificent wonders like the Grand Canyon in the United States or the beautiful limestone caves in Vietnam. Water seeps through rock, dissolves minerals, then drips down to form shimmering stalactites underground. On the surface, glaciers, another form of water, can grind down entire mountain ranges, carving out wide U-shaped valleys. In every form, whether vapor, liquid, or ice, water helps recreate the face of the planet. But water is not just a physical element. It is deeply tied to human emotions and spirit. The sound of rain tapping on rooftops, waves gently breaking on a shore, or the stillness of a morning lake all evoke in us feelings of peace, nostalgia, and sometimes creativity. Perhaps this is why, from ancient poetry to modern music, water has always been present as a symbol of life, rebirth, and infinity. Earth is called the blue planet precisely because of its water coverage. The image of Earth from space, a glowing turquoise gem, is not only beautiful but also a reminder of the preciousness of this resource. For although water seems abundant, only about 2.5% of it is fresh water, and most of that is locked in ice. The drinking water humanity depends on is, in fact, just a very small, fragile portion. This makes it all the more necessary for us to cherish and protect rivers, lakes, and the precious aquifers beneath our feet. In the future, water may determine humanity's very survival. Climate change is raising sea levels, melting polar ice, and altering rainfall patterns. Regions that are already dry may face extreme water scarcity, while others may endure devastating floods. Water, on one hand, is the source of life. On the other, it can become the greatest challenge. This reminds us even more that the fragile balance sustaining this world must be protected more than ever. In the end, water is Earth's eternal story. It never stands still, but always moves, transforms, and renews. From raindrops falling on leaves to massive cyclones spinning across the ocean, all are part of the endless cycle. And in each cycle, life is nourished, sustained, and allowed to flourish. When you drink a sip of fresh water, you may be touching a molecule that once drifted through the atmosphere millions of years ago, or lay deep in the permafrost of an ice age. Seen this way, water is not just a simple liquid, but the living memory of Earth, the stream flowing from its birth to the present. It is the very proof that this planet, Earth, the living planet, never ceases to move, to renew, and always holds within it miracles both simple and profoundly deep. The deep ocean of Earth is a place where sunlight never reaches, yet it is one of the last frontiers of modern science. Strangely, the deeper we go into this seemingly desolate realm, the more life proves its power of adaptation. Eternal darkness, crushing pressure, and frigid temperatures seem impenetrable, yet thousands of species still thrive, creating a wondrous ecosystem far beyond imagination. Deep-sea creatures are not only proof of survival, but also living works of art. The anglerfish with its glowing lure, jellyfish as radiant and transparent as glass, or squids releasing bluish-purple light in the dark, all seem to have stepped out of fantastical dreams. That world reminds us that life is not confined to light or comfort, but can flourish anywhere, as long as there is energy and a suitable environment. For this reason, many scientists believe that the subsurface oceans in the solar system, such as on Europa or Enceladus, may hide mysterious life beneath their thick ice. But the ocean is not only the stage of surreal beauty, it is also a massive biological engine that sustains the planet's balance. In the sunlit surface waters, phytoplankton flourish. Tiny and invisible to the naked eye, they are the lungs of Earth, producing more than half of the oxygen we breathe each day. While we often think of the Amazon rainforest as the green lungs of the world, in reality, the ocean is the most abundant oxygen provider, sustaining humanity and all terrestrial life. The marine food chain begins with these tiny plankton, expanding through countless biological levels, from small fish to larger ones, up to the giant whales, gentle giants gliding through the deep blue. Even the largest animals to ever exist, blue whales, depend entirely on tiny creatures like krill and plankton. That story reminds us that in nature, even giants need the small, and the fragile balance of ecosystems never allows any link in the chain to be underestimated. Deeper still, at hydrothermal vents, life relies on chemistry instead of light. Chemosynthetic microorganisms transform searing minerals into energy, opening a completely different form of existence. From this foundation, giant red tube worms, eyeless white crabs, and countless strange creatures form bustling communities. That image makes us wonder, perhaps life on Earth began in such places, where the meeting of fire and water, heat and cold, created the perfect conditions for the first chemical reactions. The ocean also serves as a mirror of the planet's past. In the sediment layers beneath the seabed, scientists find microfossils of organisms that lived millions, even billions of years ago. Each grain of deep sea sediment is a diary page recording climate fluctuations, changes in greenhouse gases, or mass extinctions. By drilling into this mud, we are reading Earth's long story, understanding cycles of warming, ice ages, and even the hidden threats of current climate change. However, the beauty and value of the ocean are neither infinite nor unchanging. Over the past centuries, humanity has exploited and damaged the seas heavily. From plastic pollution, overfishing, to ocean acidification caused by rising CO2, all are placing immense pressure on fragile ecosystems. Coral reefs, the underwater forests nurturing millions of species, are dying from rising water temperatures. Many fish species are overharvested to depletion. Even deep sea organisms, once thought beyond human reach, now face the threat of seabed mining. This raises the question, are we wasting the most precious gift Earth has given us? The ocean not only provides food, energy, and trade routes, but also serves as a colossal climate stabilizer. If this system collapses, the stability of the entire planet will be shaken. Yet, hope remains. More and more nations, organizations, and individuals are striving to protect the seas. From establishing vast marine reserves to campaigns reducing plastic waste, from offshore wind energy research to satellite monitoring of currents, all aim to preserve the ocean's healthy heartbeat. Every small action, such as reducing single-use plastics or supporting sustainable seafood, contributes to change. When we look at the ocean, we do not just see a massive body of water, but also our own future. It is the cradle that nurtured life billions of years ago, a treasure trove of knowledge yet to be unlocked, and a measure of humanity's ability to live in harmony with the planet. Perhaps the ocean is the mirror reflecting humanity, showing whether we know how to cherish and protect or only exploit and destroy. Earth, in its eternal motion, has entrusted us with a responsibility. The responsibility to preserve the fragile balance of the ocean so that this blue heartbeat continues to pulse, not only for us, but for countless generations to come. And as you listen to the sound of waves, you can feel that rhythm, the rhythm of the living planet. Our Earth is not only enveloped by oceans and atmosphere. Hidden deep within, a vast system operates ceaselessly, the mantle and the core of the Earth. Their molten rock moves slowly like underground currents, creating tectonic plates, shifting continents, and raising mountains. It is this silent movement that has shaped coastlines, highlands, and even tiny islands in the middle of the ocean. These movements not only reshape the planet's surface, but also determine climate and life. When plates collide, mountains rise, creating distinct climates and shaping ecosystems. When plates separate, oceans expand, currents are established, carrying heat and nutrients across the planet. It seems as though Earth has a profound rhythm, connected from the flowing iron core to the winds in the sky. What is astonishing is that the Earth's core itself generates the magnetic field, an invisible shield protecting life. Without this magnetic field, the solar wind, streams of high-energy particles from the sun, would strip away the atmosphere, turning the planet into a barren world like Mars. Thanks to the magnetic field, Earth retains air, water, and the stability necessary for life to flourish over billions of years. When we gaze at the brilliant auroras at the poles, we are witnessing a beautiful moment of protection, solar wind particles colliding with the magnetosphere, and that luminous dance is proof of this vital shield. All these layers, core, mantle, surface, oceans, and atmosphere, are interconnected like a synchronized symphony. They exchange energy, matter, and rhythm to maintain the planet's delicate state of dynamic balance. This is what makes Earth unique. Not a silent stillness, but a dance of energy. Powerful enough to recreate, yet delicate enough to nurture. Life appeared and developed within this dynamic environment. From the earliest ancient bacteria in the primordial ocean, life gradually shaped the atmosphere, pumping oxygen into the air, forming the ozone layer, and making the planet increasingly suitable for itself. Earth does not only nurture life, life also responds, enriching the planet further. This symbiotic relationship is what makes the blue planet unique. Today, we may forget that fragility. Modern technology makes us feel as though we have surpassed nature's limits. But just a small disturbance, a great storm, a prolonged drought, or a sudden earthquake is enough to remind us that Earth still holds control. The cycles of carbon, nitrogen, water, and solar energy still govern our lives hour by hour, day by day. When we look up at the night sky, the stars and other planets may stir our curiosity about distant life. But the more scientists observe, the clearer it becomes. Earth's conditions are extraordinarily rare. Venus, with its dense carbon dioxide atmosphere, is an infernal world. Mars, thin and frigid, lacks the gravity to retain its air. Only Earth has the delicate combination of distance from the sun, size, magnetic field, liquid water, and stable atmosphere, all forming a rare recipe for life. That wonder exists not only on a grand scale, but also in every small moment. A raindrop falls to the ground, seeps into rivers, flows to the sea, then evaporates back to the sky. A gust of wind carries seeds across valleys, planting them in new lands. A blue whale swims across oceans, connecting seas thousands of miles apart. All are part of the great cycle. If there is one message to take away, it is this: Earth is not just a place we live, but a living system in itself. It breathes, it moves, it nurtures, and it responds. And within this system, humanity is only a small part, yet one with great responsibility. We are intervening in the atmosphere, oceans, and land at an unprecedented pace. The balance the planet has maintained for billions of years could be disrupted in just a few centuries. Yet that also means an opportunity. Because if life once transformed Earth to make it more habitable, then today humanity too can become a force of preservation and protection. Technology, knowledge, and global cooperation can help us maintain balance as long as we understand the fragility and cherish the value of this planet. And perhaps when we pause for a moment, take a deep breath, listen to the waves crashing, or gaze at the starry sky, we will realize a simple yet profound truth. We do not stand apart from Earth. We are part of the rhythm of the living planet, a heartbeat flowing from the depths of the ocean, from the winds and magnetic field to every breath of every human being. If the atmosphere is the breath and the ocean is the bloodstream, then the soil is the skin of the earth. It does not reveal grandeur like erupting volcanoes or violent storms, but it plays a silent and essential role that is almost irreplaceable. Soil is the fragile boundary between the inanimate world of minerals and the complex web of life. In every handful of soil lies an entire universe where life and death, construction and decomposition unfold endlessly. The formation of soil is a long epic of patience. It does not emerge within a few years or centuries, but takes millennia. Starting from massive rocks, they are gradually eroded by rain, rivers, and temperature changes into fragments. Roots burrow into cracks, adding force to break rocks into smaller pieces. Fallen leaves, broken branches, and the bodies of dead organisms mix with minerals. Bit by bit, fertile soil forms, nurturing the life above. Each grain of soil is a story of time, a diary page of the planet. If you bend down and hold a handful of moist soil, imagine that you are holding a community more crowded than the Earth's population thousands of times over. In just one spoonful of healthy soil, there may be billions of microorganisms, bacteria, fungi, protozoa. They are invisible engineers, decomposing organic matter, recycling nutrients, and creating resources for plants. No one sees them, yet the entire foundation of agriculture and civilization itself depends on their silent work. One of the most fascinating mysteries of soil is the existence of fungal networks, threads as fine as silk but stretching for kilometers underground. People call it the underground network of the forest, a communication system where trees do not live alone but cooperate and share. A tree rich in sunlight can transfer sugars to its shaded neighbor. When a tree is attacked by pests, it can send warning signals through the fungal network so that other trees prepare defenses. Thanks to the soil, the forest becomes a community that speaks a chemical language. Roots also contribute to this wonder. They not only absorb water and minerals, but also create air channels, opening space for microorganisms to thrive while anchoring the soil against erosion. Some trees, especially legumes, form symbiotic relationships with nitrogen-fixing bacteria. As a result, the soil is enriched with nutrients, becoming more fertile for future generations of plants. It is thanks to these intricate and delicate relationships that soil can sustain its fertility over millennia. Since humans learned to cultivate crops, our fate has been tied to soil. The first civilizations along the Nile, Tigris, and Yellow River flourished thanks to fertile silt deposited each year. When the soil was good, people had abundant food and culture thrived. But when soil degraded or eroded, societies declined. History reminds us that this living skin is both generous and fragile. Today, modern science helps us better understand the importance of soil. It not only nourishes plants, but is also an essential part of the carbon cycle. Soil stores enormous amounts of carbon, more than the atmosphere and plant biomass combined. When healthy, soil locks in carbon, mitigating climate change. But when it is destroyed by deforestation, overfarming, or urbanization, that carbon is released back, contributing to global warming. Soil is a silent ally in the fight against climate change, but it can also become a betrayer if we mistreat it. Soil is also a massive filtration system. When rainwater seeps through soil layers, mineral particles and microorganisms filter out toxins, retain nutrients, and provide clean water for rivers and aquifers. Thanks to this, we can drink fresh water, a gift many rarely think about. However, this living skin is extremely vulnerable. Deforestation, intensive farming, excessive chemicals, and climate change all weaken soil. Every year, billions of tons of fertile soil are washed into rivers and seas. Soil formation takes centuries, but we can destroy it in just a few harvests. When soil is lost, not only crops fail, but the entire ecosystems that depend on it collapse as well. Therefore, protecting soil is not only the duty of farmers, but the shared responsibility of all humanity. Simple measures such as planting cover crops, preserving forests, rotating crops, or reducing chemicals can help soil recover. Every grain of healthy soil is a building block for the future. The next time you see the brown soil beneath your feet, don't just regard it as lifeless dust. Imagine that you are looking at a vast library containing the history of the planet, a bustling community working silently, and a foundation that nourishes all life. Soil is memory, the present, and a guarantee for the future. It is not only beneath our feet, but also woven into every bowl of rice, every breath, every sip of water we drink. And just like the atmosphere or the ocean, soil reminds us that Earth is a living body with delicately linked systems. We cannot separate ourselves from it. When we care for the soil, we are caring for life itself. Because ultimately, soil is not just the foundation on which we stand, but the silent heart that connects everything on this living planet.